Hi everybody, we're back for some maths. Here is our flashback 4. What I want you to do is draw an acute angle. What fraction of a full turn is 180? Subtract 4.7 from 8.3. Convert 3 3/4 into an improper fraction. It's a mixed number at the minute. Turn it into an improper fraction. Now, if you're not sure of any of these, we are going to cover some of them. In next term, I believe we cover fractions. So pause the video, give them a go. So draw an acute angle, that's any angle that is less than a right angle. So this is my right angle, so it could be any angle this side, and should be denoting that with a little round bit. What fraction of a full turn is 180? So we know a full turn is 360 degrees. What fraction is 180? So how many 180s? Of course there are 2. Therefore that's our denominator, and it is a half. You could have put 180 over 360. That would also have got you the mark. It could be anything where your numerator is half of your denominator. But the main one here is half. We know it's a half turn. Subtract 4.7 from 8.3 and 3.6. Well done if you got that. We could have labelled them out 4.7, 8.3. As long as our decimal places are lined up. I'm not going to go through that. We can look through that at a later time. So convert 3 3/4 into an improper fraction. So if we take this 3 here, we can take that 3. We're in quarters. How many quarters is 1? So before I get onto that step, we'll take this 3 and I'm going to split this 3 into 1, 1, 1. I'm going to split it into 3 wholes. Now I'm going to convert each of those into quarters. I know that 4/4 is the same as 1 whole. It's very small, I know. We're going to cover this next term, so please don't panic. So that 3 is the same as 4/4, 4/4, and 4/4. 4, 4, and 4 is going to be 12/4, but actually I've got 3/4 here. 12/4 and 3/4 is, of course, 15/4. Well done if you got that. So moving on to our lesson today, we're going to be continuing with properties of shape, but this time we're looking at quadrilaterals. Now if we take this quad, that gives us a little clue as to what we are going to be looking at today. So let's just recap. Each of these triangles, which one's which? Whoops, I showed you the answer to that one. These lines indicate they're the same size. So those 2 are the same size. It is, of course, isosceles. We've got 3 that are the same size. That must be equilateral triangle. We've got, we're indicating our angle using a square or a right angle. So that must be a right angle triangle. Which, interestingly, this right angle triangle is also scaling. And this final one is scaling as well. But that right angle triangle is also scaling. And you can have right angle isosceles triangles. You cannot have a right angle equilateral triangle. Be interesting to see if anybody can tell me why you can not have a right angle equilateral triangle. So on with today's maths. So we're looking at quadrilaterals. So we know quadrilaterals have 4 straight sides and 4 angles. These are the common properties of all quadrilaterals. Now, they may not always be the same size sides or the same size angles, but it will have 4 and 4 straight sides. So some examples of quadrilaterals is a square, which is going to be your most common one. So all sides are of equal length, all angles are right angles, and they have perpendicular lines. Now perpendicular is when a line meets at right angle. So like a T shape would be perpendicular. You might see a T junction on a road. If it meets at right angle, it's perpendicular. These all meet at right angles, they're perpendicular. And it has 2 pairs of parallel lines. Here's parallel lines. Remember, I've put the ones go together. So this has one arrow, so it's the same as this one arrow. This has two arrows, so it's the same as this two arrows. And that shows that they are parallel when you see them, like that. So that's a square. And we have a rectangle. So this has 4 straight sides. It has 4 angles. All of the angles in this instance are the same, but all our sides aren't the same. But it still fits our basic definition. 4 straight sides, 4 angles. Here we have 2 sides that are longer than the others. All the angles are right angles, and it has two sets of parallel lines again. So it has that set and it has that set. It just so happens that the 2 horizontal parallel lines are a different length to the vertical ones. Now here's an unusual shape, it's called a trapezium. The way I like to remember this is if I draw a little person here, reminds me of a trapeze artist in the circus. So these are a trapezium because it looks like a trapeze. Has anybody of interest in if any of you have seen them? Now this is my favourite act at circuses. I really like Cirque du Soleil. I've seen it quite a few times. And the trapeze is always my favourite. So not all trapeziums look the same. This is a basic trapezium. Generally speaking, your trapeziums will be symmetrical down the middle, but not all of them. Like this one isn't symmetrical down the middle. This is at a slightly different angle to here. But it will have 1 pair of parallel lines, and that will be these. This is not parallel to this because we know that it will meet. It will form like a triangle. It has 2 sets of equal angles, and it has 2 lines of equal length and 2 that aren't. And it has 2 obtuse angles and 2 right angles. That's a trapezium. A parallelogram. Now the clue for this one is in its name, parallel. 2 pairs of parallel lines. This is 1 pair of parallel lines. That's the second pair of parallel lines. It has 2 acute and 2 obtuse angles, and it has 2 pairs of sides that are of equal length. So my 2 are the same, and my 1s are the same. It's different to a trapezium because these 2 might be the same, but these 2 won't be the same. Length, that is. A rhombus. Now you'll see this drawn very differently. It's almost like a square or a rectangle has been, so we call it skewed. So one side has been pushed one way, the other side has been pushed the other way. So sometimes, but not all the time, the sides are of equal length. It has 2 pairs of parallel lines. There, 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 there. And the opposite angles are equal. And that means this angle is going to be the same as this angle. And you wouldn't normally do it like this, but I'm just going to demonstrate that those 2 will be the same as well. So that's a rhombus. What I want you to do is just on a bit of paper, can you draw 2 parallel lines? The clue in parallel is here. Do parallel lines ever meet? Hopefully you've said they don't. Parallel lines are 2, well, I haven't used a ruler, but you will, 2 straight lines that will never meet. They have to be the same distance there as they are there. Because if it's slightly smaller, like that, so that's not parallel, that is. If I drew that on, they would eventually meet. And no, they don't ever meet. Think of it like a train track. That's the definition, that's like the image that you see quite a lot when you're learning it. They have these bits of wood in the middle that are the same size, and it helps to keep them separated. If it got closer, the train would come off the tracks. So, whoops, I don't know why that has come off. Here is a way of classifying quadrilaterals. So if it's got 4 equal sides, we can put them in here. If it's got at least 1 pair of parallel sides, it can go in here. Has right angles, has no right angles. Do you know what this is called? This diagram's called? We call it a Carroll diagram. We use it for sorting. We've used it before, but we did it with numbers, so you might have odd and even. It's a brilliant way to separate, classify things. And here we have a different diagram. Venn, V-E-N-N. So that's Carroll. That's a Venn diagram. So everything in here will have 2 acute angles. Everything in here will have one-sided parallel lines, and things in here will things in there will have both. And things outside, which lots of people forget, has neither. Neither, neither, one of the two. Doesn't have 2 acute angles and doesn't have 1 pair of parallel sides. Longer length. Okay. What I want you to do, I want you to give it these questions a go. Remember what those lines mean. Give this a go. Is it a polygon? Is it not? What's the number of sides? What's the number of right angles? Have a go and then get to draw your own ones.